Hello YouTubers, this is a new session where I get to continue with you our journey into building an MCP based artificial intelligence LLM architecture. In the last session we talked a little bit about how to build the simplest MCP server. That's Model Context Protocol, which is basically a tool or a resource, a server that holds tool, resources, or intents as in context that allows LLMs to communicate with it, and be able to get some real-time resources, real-time data, and whatnot. A big example of that, if you want your LLM, your offline local LLM, to be able to go out there and get you the latest details in the news or the weather today, the temperature, whatever the case may be, your classic traditional fine-tune training or even vector embeddings might not be the best option for that, because you don't know if this data can be stored in a local storage. You don't know if, fine tuning that, by the time you already finalize fine tuning your model, the temperature would be a completely different thing. So you want something to tell your LLM, here's real time data that you can respond with. And in the last session, we talked about how to build a simple one. Let me kind of just remind you of the architecture here, what we're doing. Last time we said here's an MCP server, right? Here's an MCP server, simple server. And servers, they contain what? They contain three things. They contain tools and context like intents, right? And they contain resources. So there's tools, resources, right? And context, intent, right? And your MCP server is able to communicate with your LLM, your client in general, whether there's an LLM behind it, and that's exactly what we did last time. We basically said, here's a simple client, has nothing to do with AI here. We're just kind of client server. You may as well be calling a RESTful API, right? It doesn't matter. And we basically went and did this guy, and we said, hey, there's a function called addition, and take X and Y, and go ahead and give me these values, right? That's basically this area here. That's what we did last time, right? Let me kind of show you, just as a reminder, where that looked like. So if you go into simple MCP, it's on GitHub. You should be able to, I'm going to drop the link here in the comment for you. If you go into the server side first, we basically, when it's literally 2 lines of code and a model with a bunch of things in it. So basically I went and said register this calculator tool. The calculator tool is an MCP tool with a description. And then it has this addition kind of name, and it basically adds 2 numbers. I don't know why I added 100 here, maybe just to confuse myself. But here you go. Basically just a simple MCP server. And when you run that server, and we're going to run it right now, if I go to the client here and say, okay, here's a client, here's the location of that executable where the server is, I'm going to send you a bunch of information, and I want you to run it for me. Check it out. I said here 5, let's make it 50 plus 10. Run that guy real quick. There you go, 160, right? So 60, 160. Oh, it still has the, I suppose 50. Let me go back to the server here. Yeah, I did remove the, let me rebuild everything. Let me rebuild everything. Ah, the server is locked. Hold on. So I need a PowerShell to kill that server. There you go. Yeah, let me rebuild all of that. And then let me run this real quick. There, 60, right? So 50, that would have confused us a lot if we didn't catch that. So 50 plus 10, 60, no problem. Go and add, make that call tool async. Put the location of the tool. You already defined where that server is, whether it's hosted or something running locally, whatever the case may be. And then you go and hit that server, and it gives you back the details that you need. Okay. So that takes care of that part, right? But that's not enough, right? We want to actually make this intelligent, as in someone is going to come in and send a prompt and say, what is 5 plus 5, right? And this prompt will go into the client, which in this case would be your LLM, large language model, and this guy will actually know that it needs to call this addition kind of function in your MCP server. What does it take to do that? What does it take for us to be able to do that? Well, for starters, the LLM response needs to go through some processing and deserialization, to be able to kind of give us back a more deterministic response. Now, listen to me very well, because the biggest issue in the industry today, if you're listening to this, you already reached that cutting edge part of the industry, which is a problem a lot of people are trying to solve, which is like LLMs are not deterministic. Like you could ask it literally the exact same question over and over and over, and it's going to give you completely different answers. And if you don't believe me, let me show you a quick example. I'm going to run a little offline model for you with Mistral in here, and I'm just going to ask and say, you know, what is 5 plus 5? Watch. The result of 5 plus 5 is 10. Okay, I'll ask it the same question again. What is 5 plus 5? Watch. Well, this jerk. Let's see. What is 5 plus 5? Okay, let me let me shut it down and run it again, and let's see what it says. Hold on. What is 5 plus 5? There you go. Look at that. You know, I literally asked it the same question, shut down the program, and I ran it again, and now you're dealing with a completely different thing, right? It was saying the result of 5 plus 5 is 10, and now it's giving me, I wonder if it's something about the memory of it or the initiation of it. Is that how it's going to be? Ah, interesting. I learned something new today. But look how sometimes there's a space, sometimes there's no space. Don't worry about that open closing prints because I added that to kind of break the thing. But every single time, you know, you open it and close it, it's going to give you, anyway, that's just long-winded way of me telling you it's undeterministic. It basically not something you can rely on, you know, and we need that reliability, right? We need to have that kind of reliability. So how are we going to do that? In fact, the response, the architecture here, watch this. The architecture here is going to change dramatically. I'm going to take that LLM, I'm going to take that out. And the output of this LLM, the output in here, that's the response, is going to have to go through some processing and serialization. So this is deserialization. Let's just say processing. Right? It's going to take that response and it's going to evaluate whether this response has what it needs to be able to communicate with an MCP server. And if it doesn't have what it needs to be able to communicate with an MCP server, then it's not a good response. Then the processing needs to go back to the LLM and be like, do better, try again. You know, your response is not good, try again. In order for you to do that, to make that happen, this architecture right here can give you almost 99.9% success rate. Because what's happening here is that you're going at it a different way. You're not trying to restart the LLM just like I did right now, like reinitialize the LLM just to get a different answer, which is sometimes very successful, but it's also expensive from an architecture standpoint. Instead, you're basically going and saying, hey, does it fail? Try again. Fail? Try again. Okay, I'll show you that path right now, and I'll show you what we're going to do. First of all, remember, prompt engineering, right? One of the biggest ways you can minimize the risk of a non-deterministic nature of LLMs is prompt engineering. Prompt engineering, right? It's not just for people to ask ChatGPT, you know, just generic questions or simple questions. It's for software engineers too to interface with that LLM. There's nothing else you can do today to interface with an LLM except through prompt engineering. It's literally text-based. So the only thing it can understand is for you to ask it a normal human question, but it's going to have to be a really smart question. And that's exactly what we're going to do together today. So let's go back to our code. Let's go here. And what I'm going to do, I pulled in the LLM with Llama Sharp, right? Take a look at this. It's a very simple C# code that will allow you to kind of actually talk to an AI server. I'm gonna kind of break this apart here a little bit, kind of comment this area a little, and I'm gonna say, okay, here's my gguf path. I need a gguf path. Where's the path for my gguf? Let's see here. I have one saved right here. There you go. So that's my LLM. And I'm going to go and initialize. So this is LLM chat new LLM chat. Should go and add the reference for me. Great. And then I'm going to pass the LLM. Fantastic. And I'm going to ask it questions, right? Since this guy is returning a yielded awaitable for each, so it's basically sending me back token by token by token, right? What I can do here just to test it, just to show you, is I can go and say await for each, right? And then response equals await LLM chat dot send async. And here is your prompt. What is the capital of France? And I'm going to go here and say console write, not write line, because then it will look really weird. Response, like that. So every time it gets an answer, I don't know how to write for each apparently, in that guy, it should basically, and I don't think we need the await in here anymore because we have an await right here. Okay, let's run this guy first. Let me just prove to you that this is actually talking to a Mistral local LLM. Watch this. As the answer is coming, it's printing it out. Watch the capital of France. Is there anything I can help you with? Blah, blah, blah. Right? I wonder if I asked it the same, oh, now that it's shut down, it's reinitializing, it's going to give me a completely different answer. See, this is a different answer. It's the same correct answer, but the format of the answer is different. The capital of France is Paris. Okay, so now we know that this guy works. Now, let's teach this guy. I have a special prompt. Remember prompt engineering? I have a special prompt for this guy that basically will tell it. I'll go here at the server side. Instead of saying you are a friendly, helpful assistant, I'm just going to go and say you are an assistant that always, watch this, always responds with the following JSON format when asked to add two numbers. And here's the format. Watch this. This is the determinism part of this whole story. I basically went and said, you could respond and scan and, see. No, I want you to extract the first JSON object that comes out of that response. And I want you to go ahead and put it in that format. So this format here will basically say this is MCP, this is a function, this is parameters, whatever. And when you get that response, extract that JSON, serialize it, and send it to the MCP server. It's very reliable this way. It's very easy to manage this way. So let's try this again. If I say to this LLM model, what happens when we add 5 to 20? Watch what happens. Watch the response. Come on, come on, come on. Watch. It's building you the model. Watch. Very reliably. Offline. This is not a smart running in a server kind of thing. Watch. And then it's trying to kind of be nice from its own and it's adding it for me. But I don't care about that. I really care about this part right here. This part is the part that matters because this part right here is something I can extract from that response and I can turn it into hard-coded, strongly typed C#, right? Let's do that. So since I have this, I need a couple of functions in here. Let's just take the noise out. The first function I want in here is a function that extracts just that JSON. I only want this JSON. It's a little bit of a complex function. It's probably a better way to do it. But I'm trying to kind of implement a theory here and let you kind of dream with me, right? So extract first JSON object. It'll take a text, it'll find the first open, and it will go scan through it until it balances it out, and then it closes that squiggly bracket. Okay, that's one part. The other part is I want something out there to basically give me these models, right? I need the models, right? The model that do you remember like this little model that I have in here? I need a C# object that represents that for me. Now let me show you a cool trick that you can do in Visual Studio. Watch this. Let me collapse all of that. In Visual Studio, you can actually go and say edit, paste special, and paste JSON as classes. Click, boom. It took a JSON, like what's actually in my clipboard is this JSON. But in Visual Studio, if you go do that, it will actually paste it for you this way. Just a nice trick that I wanted to show you. But I actually don't want this kind of object. I want a better naming cleaner kind of naming convention, whatever. So you're gonna have to. It helps when you're kind of doing a POC on the fly, but I like this more. MCP root. It has the MCP. The naming convention is clean. It's less trouble this way. Okay, so what did I do? I had a function that will extract the JSON object from the response if it exists, and then we're gonna serialize that guy, and then we're gonna send it over the wire to our MCP server. Let's see what that looks like. Watch this. So here's the serious stuff. String full response, right? And that full response doesn't have anything yet. Just for funsies, I will keep the console right line so you just see what's going on. And I'm just going to keep appending that response. So I'm collecting the rest of that response. And when it's done, I'm going to go here and say, that's my JSON. Extract JSON from that full response. Great. And then we're going to serialize, right? So this is your MCP root right here. And this guy is going to basically say JSON convert.deserialize object with MCP root, and it takes in the JSON in there as a parameter. So you see what I did there? I basically said, hey, go ahead, LLM, respond however you like, right? And when you're done responding, I will look for the instruction that I gave you. And if this instruction is a good JSON, I'm going to go and try to serialize it. Once that's done, I can now go back to my nice MCP server in here, and I can go and say, okay, out of this MCP root dot MCP dot function dot name, that's the function name, and I don't have to add those anymore, because what I can do here is to basically go and say MCP root dot MCP dot function dot parameters dot to dictionary. Watch this. And here's your first parameter, parameter dot name, and your second parameter, parameter dot p parameter dot value. I think that would do the trick for me. Let's see. And then close the parens. So you see, now this is a completely different world we're in. Instead of actually passing specific values and function names, I'm basically saying, hey, give me that response, turn it into JSON, serialize it, pass that serialized to the server, and then fly. Now let's see if that works for us. I'm going to say add 500 to 20. So it should be 520. Let's see if it actually hits our server. Assistant, it's printing out the nice. See, I kept that for debuggability. Oh, I made a mistake. Watch this. The mistake here is that my function on the server is called addition, but my thing in here says add two numbers. I should say addition. You have to stick to the function name. We'll get to that part as well. So let's run this guy again. This is it. This is the end of the road. Let's do it. Here we go. MCP. Addition. Parameters. 500. Oh, this is very beautiful. Watch, watch, watch. Okay, so it's doing it on its own, but now, there it is. It called the server and it gave you 520. This guy right here. Not this guy. This is the LLM trying to be smart. It's this guy. And it's super reliable, guys. I'm telling you right now, I could run this 50,000 times and it's still gonna work. I promise you. Let's try it one more time. Just for the road. One for the road. Mm. See, now it's hallucinating, which I don't care about. Look, 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 it's hallucinating. I don't care about that. I want it to hit my MCP server. Oh God, it's going crazy. Just wait for it. It eventually is going to get tired or run out of context tokens, and it's going to pick up the first JSON object, and it's actually going to give me the answer. Let's see. I don't know. There it is. 520. It actually did hit the server, even though it got stuck halfway. Look, 100 to, so this definitely that 520 didn't come out of this object. It was the actual response. To make it super clear, just so everyone know, Hassan, this is definitely part of the generation. I'm going to go here and say, watch this, because I'm having fun, MCP server response. So you know that this is not some hallucination from an LLM. It's actually what's coming back. Here we go. How reliable is this? Can you believe it? You could run it 50 million times and it's still gonna work just fine. It's about the prompt, it's about the little details that makes it really important, right? See, it's trying to answer like, there you go, MCP server 520. Now, here's the cool part about this. It doesn't matter what the input is gonna be. Like, I can go here and say, give me the outcome of 22 added to 55. Okay, that's 77. Let's try this. So I'm changing the language. I'm changing how I'm talking to this guy. Mm, beauty, beauty. Look at that. Look at that. Response from the server, 77. Okay, so this is gold, right? Because that basically means that you could work around the issue with the determinism, non-determinism issue in the server much, much easier. Much easier this way. I haven't added the fallback mechanism in here. We could add that, as well. I'm sure you can add that yourself. If this JSON is null, MCP root is null, go ahead and fix it, right? Go ahead and try again, restart the server, figure out what your model is. Go agentic, go full agentic, self-correct and all that. I'm gonna put that code for you in the server. I hope, so that takes care of this whole dealio, like all the way down from here to here, right? You can now reliably build an MCP server. Like imagine if what's sitting behind that LLM or what's sitting behind that MCP server is like an actual RESTful API, right? And that RESTful API actually goes and picks up the weather for you and comes back and gives you these details. Now you have this amazing reliability where you can take any kind of input, any kind of prompt, and it goes through the LLM. The LLM will produce something based on the instructions. It'll find the right MCP tool and then boom, call the right MCP tool and get the right answer from there. Of course, architecting AI solutions for the enterprise is much more complex than this, right? There's fallback mechanisms. What if the API is down? What if your LLM is completely hallucinating beyond the retry point? So many things I can't wait to share with you. I want to especially thank everyone who liked and subscribed to this channel. You probably can see up there we have reached 100,000+ subscribers. I'm very grateful for everybody who just watched, hit a like, dropped a comment, or hit subscribe. Please share it with your friends. Share it with the people that you think these videos are useful for. We're going bare bone here. I'm not trying to sell you a cloud service or a cloud infrastructure. I'm telling you, build it right there on your machine. Run it on your machine. Build your own LLM because the future is all AI, and this is what this is all about. If you have any questions, comments, concerns, please feel free to drop a comment in the comment section, and don't forget to like and subscribe. I can't wait to share with you more stuff. Take care.